What's up, boys and girls? Here we are in Chapter 11, Lesson 2. And this lesson is all about degrees. Degrees. Now, degrees has several meanings, but in this instance, we are going to talk about the degrees of angles. And all of the angles are going to be in a circle. Okay? So, number one, they already did that for you. It says that this angle, oh, I forgot to read the directions. Tell the measure of the angle in degrees. Okay, so this angle is 60 degrees. And do you notice that they have a fraction in there? 60 over 360. Okay? Going completely around a circle, adding all those angles, is 360 degrees. And sometimes it's easier to look at it this way. And I'm sure you did this in class today or yesterday. But you know all about right angles. That's a right angle. That's a right angle. That's a right angle. And that's a right angle. So those four 90-degree angles can be added up or multiplied to figure out how many angles are in a circle. 90, right? 4 90-degree angles. 4 90-degree angles. 4 times 0 is 0. 4 times 9 is 36. Okay? So to go all the way around, to make a circle, all the way around a circle with angles, it's with degrees, it's 360 degrees. So every circle that we work with, the whole number of degrees is 360. That's why, oh, I kind of covered it here. That's why, I'm going to rewrite it. 360 was in the denominator because that's the whole. The number of degrees in a whole circle is 360. Okay, so let's look at number 2. So clearly half the circle is shaded and it's a straight angle. Okay, so what is that angle in degrees? You probably already know that one. A straight angle, watch this, okay, is really a 90 and a 90. Okay, so what's 90 times 2? Well, 9 times 2 is 18. Add that 0 on. That is a 180-degree angle. So if you are facing one wall and you jump and you face the opposite wall, you did a 180-degree turn. If you skateboard or if you snowboard or anything like that, and they call those turns 180s and 360s, that's what they're talking about, the degrees of a circle. They're spinning around in a circle. All right, let's take a look at number 3. So that's 1/4 of the circle shaded. Oh, wait a minute. Look at this, guys. Hello. That is so helpful. Thank you, right angle mark. 90 degrees. Okay. Now, some of these are a little more complicated, and I think we're going to do one more of these on this page too. But awesome job on this, guys. Really, I would say that the sample one was the trickiest. We didn't have to do that one. All right, let's keep going. All right, classify the angle, right, acute, obtuse, right, or straight. Okay, so number 4 is a 25-degree angle. And you guys have learned that anything less than 90 degrees, which is right there, and so look at that, 25 degrees. Oh, you little itty-bitty angle. You little cutie, right? I know that's what your teacher says. It's just a cute little angle. So let's look at number 5. So number 5 is marked as 110 degrees. And we know that anything over a 90-degree angle, so, is going to be the big boy, obtuse, right? So this angle I'll trace in red. Woo! It goes way out there. Oh, I didn't trace it very well. There it is. That is definitely greater than 90 degrees. So we will classify that as obtuse. All right, here we go. So now we have to classify the triangle. We're going to classify it by the angle. It's going to be either acute, obtuse, or right. Now you've probably done a lot in your class building triangles and looking at the angles and trying to figure out, can I have two obtuse angles in a triangle? Can I have an acute, obtuse, and a right all in the same triangle? You've probably done a lot of hands-on things with that, I bet. So let's take a look at number 7. I see an acute, another acute, and I know that because look at that. They're labeled, and those are both less than 90 degrees. And then up here, I've got another labeled angle. It's 90 degrees. So if there is one right angle in a triangle, what do we call that? A right triangle. Okay? Perfect. All right, look at number 8. I see acute, 30 is less than 90. I see obtuse, 110 is greater than 90. And I see acute, 40 is less than 90. So that, definitely not acute, because acute has all 3 acute angles. Obtuse, that's going to be it, right guys? An obtuse triangle has 1 obtuse angle. All right? Oh my goodness, there we go. All right, excellent. So far so good on this chapter, right guys? You're doing fantastic. All right, so now we're going to look at the bottom at problem solving. It says, Anne started reading at 4 o'clock p.m. and finished at 4:20 p.m. Okay, so these two clocks, there's a start and an end, and they just have the minute hand going around, right? 5, 10, 15, 20. Okay, check. Number 10. Through what fraction of a circle did the minute hand turn? Through what fraction of a circle? So this one asks about the fraction of a circle. Let's see. Well, let's think about this, guys. A clock is divided into 12 equal parts by the numbers, right? So it went 1/12, 2/12, 3/12, 4/12, right? It went 4/12 around the clock. But I'm going to think about 4 and 12. 4 times 3 is 12. Oh, so hold on, guys. I want you to notice what I'm going to do here. 1, 2, 3, 4. 1, 2, 3, 4. I just drew a picture of 4/12 in simplest form. I divided 4 into its 4. I divided the 4 parts by 4, and I divided the 12 parts by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So this fraction of the circle, this shaded part, it is 4/12, but in simplest form, it's 1/3. So I want to write both of those. 4/12, and then I'm going to write is equivalent to 1/3. All right, let's go on to number 11. How many degrees did the minute hand turn? Oh, see, now this is the one. Remember I said at the beginning that those were pretty straightforward and that they'd get a little trickier? This one's a little trickier because it's not 180 and it's not 90. It's 1/3 of a circle. All right, so let's go back and think for a second. How many degrees, because now we're working in degrees, how many degrees are in a whole circle? 360, right? Okay, so 1/3 equals how many out of 360 degrees? Okay, guys, so if this circle all the way around is 360 degrees, how many degrees are in 1/3 of the circle? So that's basically separating 360 degrees into 3 equal parts. Now, what operation is that, guys? When we have 360 degrees and we separate it into 3 equal parts, division, right? Remember that from way back when? So 3 equal parts into 360 degrees. And when we divide this, the quotient will be how many degrees are in one part. Okay? You might actually know this one mentally, right? Do you know how many 3's are in 360? Or actually just in 36. So let's do long division though. 3 into 3 once. 1 times 3 is 3. Subtract. Bring down the 6. 3 into 6 2 times. 2 times 3 is 6. Oh, sorry about that. 0. Bring down the 0. 3 into 0. Boop. Can't do it. So we have to put a 0 up there in the quotient. So each of those thirds is 120 degrees. This is 120. This is 120. And that's 120. Now, you know what I'm going to do really quickly? I'm going to do 120 times 3. Now, what should we get when we multiply that, boys and girls? We should get all the degrees of a circle, which is 360. So let's see. 3 times 0 is 0. 3 times 2 is 6. 3 times 1 is 3. 360 degrees. Okay? So the minute hand turned 120 degrees. Okay? Awesome. Really, really awesome, guys. Oh my goodness. I left this one so teeny. Oh well, we can do it. We can do it. Okay, let's check number 5 here. Jeff said his city got 11/3 inches of snow, which shows this fraction written as a mixed number. Okay, so, well, this gives me a lot of workspace, doesn't it? They want to know 11/3 written as a mixed number. Now remember, a mixed number is a whole number and a fraction. So 11/3 equals some whole number and a fraction. So remember everything you know about fractions, guys, because look, we're going back to chapter 7 right here. Chapter 7, lesson 6. You know that you have 11 pieces and it only takes 3 pieces to make one whole thing. Okay? So how many whole things can you make with 11 pieces? Well, let's see. There's a whole thing. There's 3 pieces. That's 1. There's another 3 pieces. That's 3, 6. We've only used 6 pieces out of the 11, and we've made 1, 2 whole things. There's another whole thing made with 3 pieces. So that's a total of 9 pieces. 3, 6, 9, right? And that's 3 whole things right there. 1, 2, 3. Okay, can we make another whole thing? Do we have enough pieces? 9, 10, 11, 12. Nope. We only have 11 pieces. So with 11 pieces, we made 3 whole things. But we only used 9 pieces. So what do we have left over? How many pieces are left? Let's see. We had 11. We used 9. So 9, 10, 11. There are 2 pieces left. And of course, 3 stays the same. So sorry about this being so teeny. 3 and 2/3. I'll say in a teeny voice. And remember, guys, that this is basically division. It's division. 11 divided by 3. Okay, let's just do a division. 3 goes into 11, 3, 6, 9, 3 times. 3 times 3 is 9. Subtract 2 left, and then we take that 2. 3 is the whole number, and 2/3. Remember that, guys? All right, awesome. Let's see. One more, it looks like. Oh, no, look, this is a blank slide. I had like an episode on this one, boys and girls. Well, I hope you have a great night. And Mrs. Olvey loves you. You're wonderful.